Like, hi, by learners, here we are being introduced in the very last, more like the summit of everything, like what we have had in the variation. We have been introduced into the direct variation, introduced into the inverse direction, joint, and now the very last, we'd like to discuss something about partial. Right. Here, it simply means there are some quantities which can vary one partially. Like, so let us look at an example first where we can describe the quantities which are varying partially. Partially simply means the existence of one quantity is coming out on the is coming from the difference or sum of other two quantities. For example, suppose you are traveling a certain distance, right? And we describe issues about the fare. Let me talk of a bus fare. Here we are. Let's have the bus fare. It's just like the amount of money that you're going to pay for you to reach a particular destination. What is there in the bus fare? The charge, most of the times, depends on the interest of the owner of that vehicle. For instance, the owner of the vehicle may charge a passenger in several ways. Like, say, for example, one, the fare can come in relation to the distance one is going to travel. In this case, the distance can be represented by letter D. Meaning to say, the longer the distance, it means we're going to pay more, and that is it on the ground. I start maybe from Lilongwe, I'm going to Mzuzu. The amount of money one has to pay from Lilongwe to Kasongo is quite different from the amount of money somebody can pay from Lilongwe to Mzuzu. So here it means that, say, the cost can depend on the what? On the distance that is covered, and that is obvious. But now here we are. You find that most of the times when you are traveling the bus and the bus has reached a certain destination, that bus most of the time becomes dated. People eat different types of food stuff, and they litter the bus, lot of peppers. Some can even vomit in the bus. Such that the space inside there, it's just like the place inside the bus there, it's just like nasty. Such that if we are talking of the foreign desk arrangement for the travel, it may not be on if we can take that bus in that state. That bus must be cleaned up. And it's just like now, who is going to clean so that tomorrow the customers can be attracted and be able to board that particular bus? So that now it takes to the bus owner be able to think, if they are going to use part and parcel of the money that he was using when these customers were paying, which depends on the distance, then the guy can sometimes make a loss. So this person, what he does is this. A person who is going to board that bus is going to pay a certain money that depends on the distance that is covered. And now, if we talk of the issue about cleaning the bus, what he does, he just charges every customer who gets in that bus and pay a certain amount of money, which does not even consider the distance covered. Because one can travel a short distance, can be able to last everything in the bus. Someone can travel a longer distance but cannot do anything. Can just make things which are very hygienic in the bus. So what now he said that in this case, I think, what if every customer who get in my bus has to pay a certain amount of money, which is not, they are going to be charged depending on the distance covered. So it's like when you go and board this particular bus, you are going to first of all going to pay a certain amount of money. Everyone, that amount of money is there meant for hiring somebody who can clean the bus once it is dirty. Right, because this bus owner does not want to use the money that is used, that is obtained whenever these passengers are traveling, because that is part and parcel of his profits. So he said, no, the cleaning itself should be separate. So he says, like, every person who bought my bus can sometimes pay first of all, 1,000 kwacha. So when getting to the bus, you first of all have to pay 1,000 kwacha. But he does not reveal it out. to say, well, first of all, we're going to pay a certain amount of money, which is 1,000, meant for cleaning purposes. Then thereafter, he said that, oh, once you have paid this 100,000 or 1,000 kwacha, then that 1,000 kwacha has to be added with the amount of money that you are going to pay depending on the distance that you are going to travel. Right. So in this case, there will be a certain amount of money that you are going to be paying. That should be added to the what? This amount of money that you're going to pay for what? For cleaning purposes. And this money is coming from the distance you're going to what? To cover. So now, if you talk of the distance to be covered, the distance always depends on the particular kilometer. So he may be able to do the calculations like this, as to say, for a kilometer, like say 1 kilometer, every passenger has to pay what? Maybe talk of 500 kwacha for a kilometer. So it means if you are covering more kilometers, like say for talk of 10 kilometers, that it mean you are going to multiply 10 by 500 kwacha. Then you are going to find the amount of money that you are going to pay for the distance you are going to cover. If you are going to cover maybe 20 kilometers, still more you talk of 20 multiplied by what? 500, and it goes like that. When you talk of you are covering maybe 50 kilometer distance, it means you are going to talk of the 50 times what? Times 500. So here it's just like the amount of money which is going to be paid in this case, okay, is there depending on a particular constant. You always multiply by a certain value which does not change, in this case the amount of money that they are going to pay per kilometer. So it'd be like for 10, you talk of 10 times 500. You talk of 20 times 500 if it's 20 kilometers. 50 kilometers, you talk of 50 times what? 500. It goes like that. If you talk of 100 kilometers, longer distances, you talk of 100 times what? 500. Think like that. So which means the amount of money that you're going to pay depending on the distance is just like the amount of money which is coming from two values. One is just like a value that you're going to pay for the kilometer, and then multiply by what? Number of kilometers you're going to cover. So here it means just like that amount of money is there coming up when you multiply a certain value which does not change. In this case, it's just like a constant. Let me write this 500 kwachas by a particular variable, let it be k. So it means 10 times k, 20 times k. So here 50 times k. So it means the amount of distance, the amount of money you pay for the distance there, it'll be just like k times ad as such. So it's more like you have got two constants in this case. I'm going to board a bus. The first thing I have to pay 1,000 kwachas the must. Then after I'll pay a amount of money multiplied by a certain what? A distance covered just for a kilometer. Right. I curve 10 kilometers. It means I have to multiply that 10 by a constant which is 500 kwacha. So at the end, if you are asked how much money you are going to pay, this bus owner would say your fare is into 1, the 1,000 kwacha, which is just a value, a constant for every band. So that one can be represented maybe by letter A, and then he said another amount of money depends on the distance that you are going to travel. So in this case, it means you have to multiply a constant value, like in this case, it was the 500, right? Amount of money to be charged per kilometer, times the distance you're going to cover, like 50, talk over 10, talk over 20. So that one is added here by A, which is the amount of money you pay for cleaning purposes. So it'd be like total bus fare, it'd be A plus K times D. And the total that you have from here is what you are going to pay. So in this case, we say this bus fare, which is F, that is the cost, a total cost, is there coming from two parts. One, a constant one, and the other one is the amount of money that depends on the distance covered. So in this case, we say that F is partly constant, and also partly varies as the distance that one is going to cover. Right. So here you have a good example of a partial variation. One quantity like F here, bus fare, is coming from two parts. You talk of one part, a value for cleaning purposes, and the other one is a value that depends on the distance you travel. The same when you go to the shop, you're going to buy a packet of sugar. you guys just pay for the packet of sugar like that and any other packaged commodity. You don't know where that amount of money is coming from. That money is coming from the two charges. That is the quantities or say talk of the materials that has brought that particular product. Let's talk of the packet of sugar. A packet of sugar is coming from the plastic pack and also the product itself. So when they tell you, you have to pay 3,500, you just pay it. You think that this 3,500 is only for the product inside the sugar itself. No, you have to also consider those people who design that packet, a plastic paper that it contains that product, the sugar. Was it just done for free? No. There's a certain amount here that is meant for just a packet. Because it's a different part that it is a different section that makes that plastic paper. And it's also a different section in the company that makes that product. So where they have to charge, if a plastic paper is charged to over, maybe to over, they can charge maybe 1,000 kwaja, or say to over maybe to over maybe to over 600 kwaja to make that plastic a container, and the product itself can be charged more. You talk of 3,000 what? 100. Together, what are you going to pay? You are going to pay 3,100 plus 600. If the becomes cheaper, you be talking of the here you may pay what? 2,000 what? 900 meant for the product. So here you talk of the cost of the sugar, which can be C is equal to 600 plus 2,900. A plastic paper that contains the product and the product itself. You add it together. That's what you do. A container, you talk about a tin of needle. A tin itself has to be manufactured. A product itself is a different thing. So you add the two, that and that, it gives you the total cost that you pay at the shop. A good example was partial variation. So now we talk about the quantities depend. The more quantities, you pay more. The less quantities, you pay less. So it varies that way. The cost varies depending on the two parts. You talk of one part of the container and the other one part of the products. So that's the way it goes in other scenarios about the way quantities vary with each other. Right. So here, what we have is just this. I'll also give you a very brief statement about the scenarios in the partial. To say, like say, in the formula, F, in our case, that is just like a pass fair, is equal to A plus C K D, where, in this case, F is a bus fare, while D is the cost depending on distance traveled or covered, and A K is a constant. Right. You'll be able to explain that, say, F, or say, we say, F partially varies as A and D. Right. To say F is coming from the sum of two parts, that is A and D. While this other one is just like the value that depends on the distance that is being covered. The longer the distance you cover, the more money you pay. The less the distance you cover, the little money you pay. So what is here in partial, you just have to take that, say, one quantity is there as a sum, or it can sometimes be the difference at a time. The moment I talk of the summation here, just an example about the sum, but you can also have a scenario where you can see that there is a certain quantity that is there because of the difference. Right, now let's have an example where we can see, be able to utilize the knowledge about the partial in this manner. Just one example, and be able to at least solve other problems in books, similarly as we do with this one here. Right, so issue about the constants now and again. Proportionality equation remembers what we've been doing. Now what about in the partial? All the things we discussed. How again are we going to present them out? The constant of proportionality. Talk of the equations of the proportionality. Things like that. Right. In the example here, it's a real life situation that we will also meet in other scenarios. We are told that somebody is making some shades. So you see here, there is information about it, and we're required to work out something. So let's read the question together. A cost of making a shade is partly constant and partly varies with the amount of time it takes to make it. If it takes 4 hours to make, it costs 120 kwacha. If it takes 6 hours to make, it costs 140 kwacha. Find the cost if it takes 3 hours. Right. So here it's just like we have got a cost that depends on time and a certain quantity that is constant, which does not change. So it means the total cost in this case comes in from two areas of concern. One is something, the amount of money which does not change, the customer still has to pay. And another one, it depends on the amount of time you use to make the shirt. Maybe the constant cost here can be the cost of the talk of a wool that is used for making up a shirt whenever you are doing the sewing, in that case. Like, so that amount of money is just like constant. When I come to that shop, I would like to pay for the cost. First of all, pay for a certain amount of money, which is just a constant for every customer who comes there. But the other one to be added on that is the amount of money that depends on the amount of time. You take more time, you pay more. It takes little time, you pay what? You pay less. Right, so let's try to analyze this one as we've been doing in the other types of variation. So here you can let the cost to be equal to C. Let the cost be what? Presented by C. Right. So which means this C is coming from two parts. So it would be like from what we have presented, it would be now, therefore C is equal to the sum of two parts, 1, C1 plus C2. So in this case, this C, main C, C1 is just a constant amount, which does not change. So this one should just be presented maybe by a letter a value which is just a constant itself, so it should not have a constant there. But the second one is another cost that depends on the amount of time. So if you talk of a quantity depends on something, like here depends on the time, that means there must be a constant that is there guiding, or say that is there giving us the value of that particular value. So in this case, when we talk of the other amount, depends on the time it takes. It means here we can just let the time taken here to be t, but now the cost of it can come in when you multiply by the what? By the constant. You cannot just have it. Remember what I was talking about, the issue about the bus fare, when we talk of the distance covered. For one to calculate the distance, the cost for the distance of the bus fare, you multiply a certain value for a kilometer by the total number of distance, by the what? The distance you're covering. 10 kilometers times a certain value, 20 kilometers times a certain value, so that is that. So it means that the quantity will always be there when you multiply a constant by the other quantity as such. So here this is the quantity which is not changing. is the cost 1, which is not changing, but this other cost t depends on the amount of time it takes. So there must be another constant. So as such, in here, in the partial, we should expect to have 2 constants as such. Like that, you need always have to always calculate each time you need to calculate the value of the main constants, the main quantities, which is a c in this case and a t as such. So you write here to say where my a and k are constants as such. Right, so I have to repeat a bit here. A cost c is coming from 2 parts. One is a constant amount. I've given a good example of this. Is just amount of money every customer has to pay. It does not change. But this other one is the amount of time, is amount that depends on time. Time increases, it means the cost increases. Time decreases, it means the cost also decreases. So here, for this cost here, we have to expect to have a constant there. So now the cost for this one is represented by kt. So which means when I multiply k by t, it means here I'm going to yield the amount of money that I'm going to pay depending on the time I'm going to take. Right, but this one, no constant, because it is already the constant. Had it been had another value which is not a constant, would have still multiplied a constant by another cost, because it is also depending on something else. But this one is just a value on its own. It's constant, you pay that, it does not change. But this one changes, so it should have another constant. That's why here I'm writing where a and k are what? Constant. So please differentiate the 2 constants aside. So now what are we going to do? As usual, let's first of all calculate the value of the constants, as we have been doing in the first types of variations. Right, but now we have got 2 of them, a and k. So what should be here is the system of finding these constants. It will be different. We can't use one equation, because here one equation has got 2 variables which are not known. Then in this case, it will be very difficult for us to calculate a and k at the same time with one equation. So as such, you as a student be able to at least depict the knowledge of what we have been doing in the past when you like to work out on the values of 2 variables which are not known in one equation. It's not possible. But when you design up more equations, in that case, it means you can solve those equations what? Simultaneously. So here the approach should be simultaneous equation. So what is there? Make sure that this information you have here should at least give you 2 equations that have to solve them simultaneously. So how do we do it? You find that when you come here, we are told that it takes, okay, you are told that if it takes 4 hours to make, it costs 120. It costs 120. So here, just like the main cost here, it means 120 kwacha comes in when time taken is 4 hours. So what do you do there? You come and write that one as to say when t, in this case, t is representing the amount of time, right? You say when t is equal to what? 4. Then we have what? C is equal to 120. So you can also represent here the t, you can also describe that there, the t is time, though I've already described that one out. So you can utilize this information to come up with the first equation, where the c, I write 120, where this a is one of the constant which I need to know, plus the k, that depends on time. So when the time is 4, it means I have got 4k, like that. So this is like equation number 1, because on its own cannot manage to give me the value of a when k is not known, and the same cannot manage to give me the value of k when a is not known. Then you go again to the question. You need at least find another equation. So here you'll be able to see that you have got another information here which tells you the amount of cost with a different amount of time. To say if it takes 6 hours to make, it costs 140. So you can also line that one as to say when time taken, that is 6 hours, it costs what? 140. Right. So from there, you're also going to substitute in this equation here. Yeah, this equation is always your proportionality equation. Though I've not mentioned, you can be able to analyze that this what you have here is a proportionality equation, only that it is incomplete because we don't know A, we don't know K. So with this, it means we're also going to substitute wherever the C, we write 140 is equal to what? For A is not known, for K is not known, but the time here is 6. So here you're going to multiply 6 times T. You have got 60. So this comes in as equation number 2, like that. So to find K and the A, you have to solve the two equations simultaneously. So you can use all the methods, elimination, substitution, but here the easiest you can do is just to eliminate A in the two equations, hence you use the elimination method. Right, so what do? You come up here and say from 2 and 1. You write the equation 2 here, 140 is equal to A plus 60. And then this equation 1, you have got 120 is equal to what? A plus 4T. Right. Eliminate one variable between T and the A. So here what you have is this. This is K. This again is K. Right. And here is K. Right. Let's eliminate one variable, either K or A. Like we eliminate one, then wake up for the other one. So here it's easy for us to eliminate the variable A. You can do that one by subtraction. Hence, let's subtract the two equations, like terms together aside and see what we have at the end. So what we have here is this, that when I say 140 minus 120, this gives me what? 20. And here we have got A minus A is a 0, and 6 minus 4K, that gives us 2K. Right. As such, if I would like to find the value of a constant K, in this case, it means what I'll have is just a matter of dividing both sides by 2. I divide by 2. As such, my K is equal to 10. Right. So the constant that depends on time is 10. Constant that depends on time is 10. But the constant that is just there, which is there for every customer who comes to that particular shop, is A. Let us also work out on that. So to find the value of A, what we need to do, we can select any one of the two equations and substitute for K, because K here is known as the 10. So let me go for equation 1. So I would say now in 1, and substitute 10 for a K, such that the light up now comes in to be presented like this. This is my equation 1. 120 is that equal to A, I light A, plus 4 times K, plus 4 times K, which is a 10, like that. So what will I have at the end? I have here 120 is equal to A plus what? That is 40. Right. So if I light like terms together, my 40 comes to this side, and I have what? 120 is going to subtract a 40. So here, this is what I'll have. I'll have my 120, subtract me 40, and that gives us the value of A. 120 minus 40 gives us what? 80, which is equal to A. So it means our constant A is equal to 80. Right. As usual, having worked out the values of the constants, let us now come up with the proportionality equations. Then here you come now, therefore, proportionality equations, not equations, but now an equation to be 1, but the constants here they are now 2. So it is that same what we had up there to say C is equal to A comes in as 80 plus a K Here it is a 10 times t. Right, so this is our equation of the proportionality taken up there where A wasn't known and K wasn't known. That now I've found the value of A and K, we just have to substitute where with A, we write 80, where there is K, we'll have to write a 10. Right, so you can see that whatever we're doing here, not different from what we have been exposed to in the direct, joint, and the inverse. Now, we have the proportionality equation. What next? We need now to find the cost if it takes 3 hours. Right, so lastly, it's just more like say, when t is equal to what? 3. What is the value of C? So you take your proportionality equation, come and write say C is equal to 80 plus 10 multiplied by t here, substitute for 3 times 3. Then what we have here is 80 plus 30, and this gives us 110. Right, C is equal to 110. So it means the cost will be equal to 110 kwacha. Right, so that's the way it is about partial. So just to make a summary of this, how you can differentiate from the other type of variation and how you can recognize it, you'll be able to know that one, usually partial demands 2 constants. And then for you to work out the values of the constants, bring in some approaches about the simultaneous equations, which weren't there in the other types of variations. So please, my dear learners, the questions, most of them are just the same. So try to consult different types of books. You'll be able to see that what we've discussed here is really making sense, and you're going to maximize up your knowledge in the study. So solve more and more. You find that most of them are just like the same in presentation. But rather, this is the end of our discussion in the variation. I wish you all the best in the study. Please work hard. Always get reminded by the link down here, all the videos we have had, work on them. Otherwise, thank you.